So, just to kind of frame the issue a little bit, not that long ago, we were still dealing primarily with the human side of identity and access management. And I don't want to kind of say that that's solved. It's very clearly not. There's plenty of things still left to do there, but we've come a long way, right? It's much improved over the last several years. So, where we used to be saying, who are you and what you should have access to, we're still saying that. We're still kind of smoothing out the rough edges, but we've got better answers to those questions than we used to have. But in the workload space, and particularly for agentic AI, it's really not there yet. But how we got there with humans was largely around kind of changing how we think about things, right? We went from the walled garden of if you're inside of my network, it's kind of fine. I'll be a little looser with you. It's whatever, right? But then we kind of created this sort of identity perimeter, right? Where in addition to the network perimeter, we're expecting you to go through single sign-on and use a centralized IDP and maybe use a PAM to do privileged activities and go through all of the tools that allow us to do compliance and governance and auditability and all of these other things. And so we've built this ecosystem of tools that our users go through to make all of this stuff happen. And we've figured out relatively low friction ways to do it. There's obviously still plenty of room for improvement, but there's a lot of standardization, right? Most of our users are using single sign-on to access their services. Most of our users are using multi-factor authentication. We do have some form of policy governing who can access what. And a lot of companies have some form of zero trust enforcement, posture, conditional access, just in time, things like that, right? But in the workload space, it's really not like that. And so, we've got a few new challenges here, and agentic AI makes this more challenging. So, a lot of companies, they've got a lot more workloads than they do have humans, right? Might be 20 to 1, might be 50 to 1. Some companies, it's over 100 to 1 in terms of workloads to humans, right? And these workloads can be everywhere, right? It can be a serverless function. It can be an application running in Kubernetes. It can be, your developer running an application that they're building on their laptop. Or in the modern age, it can be an AI agent. And this brings on new layers of complexity because the standardization that we benefit from in the user space really doesn't have anywhere near the same level of adoption in the workload space. And so you end up with, like I said, workloads running on any platform, whereas with your humans, it's always, a human that's got a password or a pass key and some form of multi-factor authentication, right? And then with the services that they're connecting to, humans connecting to services through single sign-on, it's either a SAML assertion or an OIDC token, 100% of the time. With workloads, it might be an API key. It might be a JWT minted by a key pair, or it might be a JWT minted by an OIDC issuer, or an OIDC, sorry, an OAuth token through, two-legged or three-legged OAuth as an example. It might be a certificate. There's just a really wide range of credentials that can be used and very, very little standardization about what credentials should be used. And so you can end up with 10 applications using 20 different types of secrets to access 20 services. And then we add a little bit of extra compounding on top of it by the fact that AI even has a few different flows, right? You've got your fully autonomous agents, which are really just another form of workload, right? They're just a slightly less predictable form of workload that can be a little harder to wrangle, but they're still just a workload. Then you've got agents that communicate through other agents. And this kind of feels a little bit more like some of the microservices architectures that have been adopted over the years. And then we've got this other bucket here where we've got these user-driven AI agents, where, the AI agent is acting on behalf of a human, but you need to know, did the human do the thing? Did the AI do the thing on its own? Did the AI do the thing on behalf of the human? Or did some other human trick the AI into doing something on behalf of a different human? Right? There's so many layers to the onion when we start talking about these agentic use cases. And it's really starting to cause some of the traditional mechanisms that we've used to authenticate workloads to fall apart a little bit. And so just to kind of recap that, you've got this sprawl of agents all over the place. You've got very little standardization about what they do and how they do it. You've got services that they're accessing that have long-lived credentials like API keys. And it's really, really hard to audit this in a way that includes the context of who did what and why did they do it. And so let's talk a little bit about today's approaches for this kind of problem space. So we talked a little bit about human IAM. I think that's pretty straightforward and well understood. There are standards in this space around, OAuth, OIDC. There's great work being done by the IETF and the OpenID Foundation and CNCF and these other kind of standards groups. Shout out to Whimsy and OAuth and Spiffy specifically. Uh, and there's a lot of good progress happening here, but we're not at the level of adoption where we can say, yeah, we've got the same level of standardization that we've got for our humans, right? And there's also still some gaps in here, like that blended identity is really still being figured out. How do you properly represent the identity of an agent acting on behalf of a human while being able to differentiate the agent from the human? And then the next mechanism that we've been using for a really long time, particularly for workloads, is secret vaults, right? A place to go put your secrets so that you're not putting them in your code or you're not storing them on your machine. This was a big improvement from what we were doing before, right? Which was just hard code credentials all over the place and hope that they get cleaned up before they get compromised. But this kind of has new risks, and what may have worked well for a lot of workloads in the past has new challenges with agentic AI. A perfect example is data leakage, right? You've never been able to social engineer a workload before, but now you can, right? There is a non-zero chance that someone will trick an AI agent into giving it the API key that it used to access a service, right? There's all kinds of tools being designed and implemented to mitigate this risk, but the risk is there. And then the other thing is this is just really hard to do at scale, right? I mentioned, my experience at Starbucks. I managed hundreds of thousands of machines out in retail stores with no physical security and no native platform identity and all kinds of unique challenges. And this is a really, really hard thing to do at large scale. And then the final bucket is kind of what we're starting to see called MCP gateways. This is really a new thing. It's rapidly evolving. They improve the simplicity for your devs, kind of offload some of the things that your devs would normally have to deal with to the gateway. Uh, Most of them don't secure identity. Them don't manage credentials. Most of them, at least right now, seem to be focused on kind of mitigating some of the other risks of AI, like prompt injection and data leakage and MCP tool access and things like that. But this is a rapidly evolving space. And so I think that some of the kind of future solutions are going to probably look a lot like what we're seeing happen in the MCP gateway space, but it's still just very young and rapidly moving. So it's hard to widely adopt, for production, right? As is the case with most things in AI right now. There's just still a lot a lot to unravel to do this with the level of confidence and security that we've kind of come to expect over the years. So, let's talk a little bit about what Ambit is doing for this and how we view this problem space. And so, we see this as just an IAM problem, right? There's a lot of IAM providers and platforms out there that have really heavily tackled the human space. There's a lot less that are tackling the workload space. And so, we kind of think of ourselves as almost like an Okta, but for your workloads, right? And so in the context of AI, this means providing identity for your AI agents. And so we do this with our identity provider, and we've designed this in a way that we can meet your workloads where they are and identify and attest them based on the attributes of their environment. And so, in Kubernetes, right, you might use a combination of like the pod name and the namespace and the service account token to really verify that a workload is what it says it is. Or, on an AWS EC2 instance, you might use the metadata service and the name of a process that's making a call and maybe the service account that process is running as, right? This is kind of a complex, it's an onion, really. There's layers to what workload identity really is. And we've designed this to be able to meet those workloads wherever they are, and be able to kind of peel back the layers so that you can figure out what is this and should I trust it? And then on top of that, we've got a policy engine that we can implement, zero trust controls, things like conditional access or geofencing or time boxing, things like that, so that you can say, all right, I figured out who this is, and it is also compliant with my security requirements, right? It's got my security agents on it, as an example. And then we give it access to whatever it needs to access. So, that right-hand side of the equation I was talking about earlier, where there's dozens of different types of credentials and different services handle them differently. We handle that token exchange so that your developers don't have to go and figure out, okay, how do I talk to Salesforce? Now, how do I talk to Snowflake? Now, how do I talk to AWS? And then figure out, how do I make this keep working? How do I refresh my tokens? How do I prevent things from leaking? All of that kind of stuff. We abstract a lot of that away. And then finally, we address that end-to-end auditing and logging by having an audit trail saying, hey, these are all of the attributes that we saw when we identified and authenticated this workload. These are the services that it was accessing. These are the credentials that we gave it. And this was the time frame in which that happened. And this gives your SOC a lot of really rich context to be able to figure out whether they're doing threat hunting or responding to an incident. What happened here and why did it happen? And so this is kind of a diagram of the demo I'm about to show you. There's an AI agent here we're calling DocBuddy. Shout out to my coworker Holden Hewitt that did most of the development for DocBuddy. And this is an AI agent that helps you deal with typos and things like that in technical documentation. And so in this demo, DocBuddy is running in an AWS ECS service, and it has the Aembit agent proxy attached into that service as a sidecar. And the proxy is what's going to handle all of the authentication because DocBuddy is making all of its calls to Anthropic and GitHub completely unauthenticated. There are no credentials in any of the configuration. And so DocBuddy will get a webhook from GitHub when a GitHub issue is opened with a typo. And then it will go to GitHub to clone the repository. And then it will use Anthropic Claude to find and fix the typo. And then once it does that, it will commit the fix back up to GitHub in a new branch. So let's demo it. And so here I've got my DocBuddy Git repo, and as you can see, I've got a typo in it. That shouldn't say topies, that should say typos. So we're going to go ahead and make a new issue. I'm going to call it typo fix and say in readme.md on line 3, copies should be typos. And then I'm going to attach the fix typo label to it so that DocBuddy knows what LLM instructions it's supposed to use here. And then click create. Then we'll give it a couple of seconds to receive the webhook. You can see it's started working on the task. And it made a commit. And then it made a comment describing that commit. So it changed copies to typos. And it even included a handy little link here so that I can go and make a new pull request to incorporate that into my documentation. Now, let's take a look at all of the policies that made that possible. So here in my Aembit tenant, I've got 2 access policies that made that all work. So the first one is how DocBuddy gets to Anthropic. And in this case, we are identifying DocBuddy by the ECS task family of DocBuddy demo, which is what I deployed it as in ECS. And then we've got our trust provider here. And this is how we are cryptographically verifying that identity. And in this case, we're saying that it must be in this AWS account, and we are validating the IAM role that is attached to DocBuddy. It must be this DocBuddy demo role here. And then I don't have any access conditions on this particular policy, but you could set some up to, say this must only happen during working hours, for example, or this only must happen if I can see, DocBuddy in Wiz or, whatever you use as a CSPM. And then my credential provider is an API key. Unfortunately, all of these LLM tools are pretty much exclusively using API keys for authentication. Uh, if I could do one thing right now in the AI space, I would love to replace these API keys with something better like OIDC Federation or Spiffy or something. But this is the world that we live in. We've got API keys, and so we need to be able to deal with them. And so I've put my Anthropic API key in here. And as you can see, once it's been put in, it can no longer be read by a human. This can only be read by a workload that has access, an access policy that gives it access to this. And even the workload doesn't directly read it, it gets injected into the network request the workload is making. And then finally, our server workload just says, hey, when you're going to api.anthropic.com, that key is supposed to go into the XAPI key header. So now let's go back to our access policies page, and we'll show you how we get to GitHub. And so we're using the same client workload and trust provider of that ECS task family and the IAM role that's attached to it. But for this, we're using an OAuth authorization code grant to get to GitHub. And so I've got a GitHub app configured. I've got the client ID and secret for the GitHub app in here. And the callback URL for GitHub to redirect to Aembit when doing the authorization. And then for our server workload, we're just saying when you go to api.github.com, that's expecting bearer authentication. So act accordingly. And that's all the access policies that made that happen. So now let's take a look at reporting. And so we can see our DocBuddy demo kicked off right here. And in my log, I can see I've got the DocBuddy demo service name and task family. And it's going to github.com. I can see the source port, proxy port, all of that. And we can see that in this next log event, we identified that client workload. We identified the server workload that it was going to. We attested the identity of that. And we identified, yes, we do need to give it a credential. And so in this event, we're saying, all right, we verified all of that. And we also retrieved and gave it a credential. And then our next request was something that did not require authentication. And this is one of those bits of context that can be useful. So DocBuddy then went to codeload.github.com, but that doesn't require any authentication. And so it just worked. But we still logged the request. And then we've got our call to Anthropic. DocBuddy went to api.anthropic.com and we identified it, we attested it, we identified that there is a credential for it. My logs moved around. And then we retrieved and injected that credential. And so that's it for my demo. I've got one slide to do a quick summary, and then we'll jump into questions. So just to kind of wrap things up, I am for your agents, your other workloads, kind of that entire non-human space. That's really what we're trying to do here. We're trying to centralize the access management and the policy enforcement. We're trying to enable you to adopt these modern authentication and better standards as they start to get adopted by the services that you're using. So you don't have to go and rewrite all of your applications when, you know, Anthropic goes from an API key to OIDC. You can just change your credential provider to say, hey, this isn't an API key anymore. Now it's OIDC. By abstracting all of these credentials from the workloads and injecting them into the request, this does a really good job of mitigating that agent social engineering thing, right? An agent can't tell me a credential that it never saw in the first place. And then we make our developers' lives easier, right? Like as security people, we need to improve the security and move our program forward. But we also need to do it in a way that enables the business and doesn't cause too much friction for our developers, because that's when these security solutions start to really fall apart, is when the developers don't like the experience they're put under, or the users in general, really. And then finally, we enable your SOC to really deal with the ocean of workloads that we're in now, by providing this kind of end-to-end compliance and auditing and logging for your agentic AI and all of your workloads.